We want to find the surface area of the portion of the sphere that lies in the first octant. I didn't say it, but I'm going to take r is equal to 2. It's good to do an example like this because we know that the area is 2 pi. It's because we know the formula for the surface area of a sphere. And now we can make sure that our ideas of integrating over surface areas or over surfaces or finding areas of surfaces using integrals matches up with what we already know. It's just a good example to do, to sort of check to make sure that everything is consistent, at least for this one. This one thing is consistent with what we already know. Okay, so there's some outline, or there's some steps that I want to outline here that I'll write over here. So one is to, the first thing, it might seem obvious, but it's important, is to determine a parameterization. So find a parameterization. And 2, this really is part of 1, find what the parameter domain is. So a parameterization for the sphere of radius 2, we've already seen this, r of theta phi, this is equal to 2 cosine theta sine phi. This is just spherical coordinates. 2, whoa, what happened there? 2 sine theta sine phi 2 cosine phi. This is the parameter. This is the parameterization. And then what is the parameter domain? Well, we know that theta goes from 0 to pi over 2, and so does phi. Phi goes from 0 to pi over 2. Clearly, I should have given myself more room. I'm probably going to have to come down here a little bit. Okay, so now we need to do the third step is in this parameterization. So this is important. It might not make sense why I'm mentioning it now, but in this parameterization, you need to come up with the magnitude of Rs cross Rt. In our case, it'll be R phi cross R theta. But you need to do this before you might possibly change to a different coordinate system. That might not make sense a lot right now, but just remember, these are the steps. Find the parameterization, find the parameter domain, and then with that parameterization, compute the magnitude of Rs cross Rt. Okay, so now we need to compute Rs cross Rt, or in this case, R theta cross Rt. So R theta is equal to minus 2 sine theta sine phi 2 cosine theta sine phi 0. Our phi is equal to 2 cosine theta cosine phi 2 sine theta cosine phi minus 2 sine phi. And so now we want to do the cross product, I, J, K. It doesn't matter whether we do R theta cross R phi or R phi cross R theta because we're taking the magnitude. And instead of making you watch me do this at the normal speed, I just sped it up. And this is going to be kind of a tedious and messy computation. So I would do it on your own and then just watch this video and see if you get the same thing. And then if you don't, you'll be able to track and see where you made a mistake. This is me doing this computation at double speed, so it is a very long and annoying computation. We can factor out a minus 4, so this is going to be minus 4 times sine squared phi cosine theta, and then sine squared phi cosine theta times sine squared phi sine theta. Now this last one, notice what's going to happen. It's sine squared theta cosine phi sine phi plus cosine squared theta cosine phi sine phi. So this is just cosine phi sine phi. Okay, and so now we take the magnitude. So the magnitude of r theta cross r phi is equal to 4 times the square root of the following: sine to the power of 4 phi cosine squared theta plus sine to the power of 4 phi sine squared theta plus cosine squared phi sine squared phi. And remember, we're taking the square root. And so this is equal to 4. Okay, so what's going to happen inside? Well, cosine squared theta plus sine squared theta is equal to 1, and they're both multiplied by sine to the power of 4 phi. So this just becomes sine to the power of 4 phi plus cosine squared phi sine squared phi. We're taking the square root of this. Okay, now each term has a sine squared phi, so I can factor that out. So this gives us 4 sine phi times sine squared phi plus cosine squared phi to the power of 1/2, and this is just equal to 4 sine phi. Okay, so the magnitude of rs cross rt, or with our parameters, r theta cross r phi, is 4 sine phi. Okay, now you might want to copy this down because I am about to erase it. Okay, so now let me just record here. R theta cross r phi is equal to 4 sine phi. Okay, so step 4 over here is to compute. It's going to be the integral theta equals 0 to pi over 2. The integral phi equals 0 to pi over 2 for, that's pi over 2, not for sine phi d phi d theta. Okay, so the inside integral will have theta equals 0 to pi over 2. The inside integral, the antiderivative of sine is minus cosine, so this is going to be cosine of 0 minus cosine of pi over 2, so that's just equal to 1. So this is going to be 4 times this, and this is just equal to pi, this is just equal to 4 times pi over 2, which is equal to 2 pi. And of course, I've written out of the visible area, but all I did was just write the 2 pi. So this was a good video because we were able to verify that the integral definition, or the integral way to compute surface area, matches up with what we already know. In other videos, we'll compute surface areas of new surfaces.